Hello. So in the last video we learned about reflection of light and some effects of reflection. We studied reflection on spherical mirrors. Okay. Now instead of mirror, if the light is incident on a transparent surface, not a reflecting surface, then instead of getting reflected back, it actually goes inside the surface. Okay. This is called as refraction. But it just doesn't go simply. Okay. It will, if the light is coming like this, it doesn't just go like this, it will deviate from its path. So how exactly does it deviate, by what angle does it deviate, all this we will learn by looking at laws of refraction. Okay, first, before looking at refraction, let us look at some effects where we have seen refraction in our daily life. One is this, you should know, when we place a coin inside water, it appears raised, no, it appears like it is above it actually, but it is not. Okay, and one more is when we have when we go to a pond or something, the fish, or if you have an aquarium in your house, if you look at the fish from above the water, not sideways, if you look at it from above, then it will appear little upward. Actually the fish will appear upward but it actually is not there, it's here. um okay, so let us look at a video also. There we will look at one more experiment where refraction is observed. Okay, let us see this video to understand.
You can perform this simple trick of making a coin disappear by using two transparent glasses and two coins. This experiment uses the properties of refraction of light. You have to perform this trick by viewing the coins from the side and not from top. So try playing by viewing it from different positions and see in which cases can you make the coin disappear. First take these two coins and put one coin underneath the glass and one coin inside the glass. Now start pouring water in the glass and you will see the coin actually disappears. You have performed the trick. Now if you pour the water inside the other glass where the coin is sitting inside the glass, you can keep seeing the coin. Of course, if you go above the glass and start seeing, you will see the coin in both the cases.
okay, so here see the coin appears raised. This is also because of refraction. Here, because we are viewing it from the side, we are not able to see the coin at all because the water is bending the light, and so that's why we are not able to look at the coin. Let us actually see this diagram here, we can understand it. See here, because the light travels, first of all this is glass that also bends light, then water, then glass again. So there are refraction happening at multiple surfaces here. So because of that, we cannot see the coin. So this is a simple trick to perform to show refraction. Okay, now let us see what refraction is and let us go into the details. Okay, so not just that. Okay, also when we look at it from underwater, look at objects from underwater, if you are if you have done swimming sometime, then you will be able to relate to this. So when you look at anything from underwater, it appears shorter. So if you see somebody from underwater, they appear shorter. Similarly, the trees also appear shorter from underwater. This is also because of refraction. You can explain this by using refraction. Okay, also this glass slab is a perfect example to show refraction. Okay, so for example, if you have a glass slab at home, before everybody used to have a glass slab at home, for paperweight people used to use, but now I think there are so many designs of paperweight, glass slab hardly anybody uses, but in the lab the glass slab should be there. Okay, and if you put a laser to it, this laser you can get it anywhere, no, in ಜಾತ್ರೆಗಳೆಲ್ಲ ಸಿಗುತ್ತಲ್ಲ ಆ laser, you can, if you use that laser and put it, instead of going straight like this, it actually bends and goes nicely. You can see refraction here. So there is an experiment also based on this to understand refraction. It is even given in the textbook. See here, refraction of light, refraction of light through a glass slab. So here they have given the steps that you have to follow for this experiment and observation and everything. But instead of reading this, let us look at one more video. Okay, so first, this is a drawing board, a wooden board. On that she has put the white sheet and she has put pins to hold the white sheet in position. Then she has put the glass slab here, and she has drawn a boundary around it. Okay,
and almost through the center of the
and
glass
then here she has drawn a line which is at the center. It will actually act as the normal. Okay, not just like how in reflection we used to draw a normal for reference, here also we will draw a normal for reference.
We point that mark and we draw normal. So we observe that we've drawn a normal. After that, we also draw the outline of the glass slab. So
then what she is going to do is she is going to draw the incident ray. That is, let us take some particular angle and draw the incident ray.
Mark approximately 30 degrees angle.
Okay, so she has put 30 degrees and she
from
is
the
going to
normal
draw.
And join it to the normal and the boundary of the glass slab.
So angle of incidence will be 30 degrees. This one will be 30. Now she is putting the glass slab. Let me skip these parts. So now she has put two pins here. Okay, now what she is going to do is she is going to look at these pins from the other side of the glass slab, and she is going to place two more pins so that they all appear to be in the straight line as seen from here. Okay, let us see that.
Now we have to observe these two pins through the glass slab. To do so, you have to bend a little and observe the position of the pins. Wherever the images of these two pins will fall, you will have to place a third metal pin after the images of these two pins.
So she is seeing the pins from that side by looking through the glass,
so
by
bending.
bending.
I have put the third metal pin here.
And she has put more.
Similarly, we will take another metal pin. After I observe the images of these two pins and the position of the third pin.
She is going to put one more pin so that it appears in a straight line. Okay.
Our aligning.
Then she is just going to join those points. She is going to make the ray. That will be the refracted ray. Okay. And then she will join.
Our angle of incident line, the normal here. And if I extend the line.
Okay. So she has joined all the points. So we can see that even though the pins were here, when we look at these pins from here, that is from through the glass slab, they appeared as if they were here. So there is a shift. Okay, there is a shift. Instead of this being the straight, this being the line, it has shifted. So this is actually called as lateral shift due to refraction. So this experiment is kind of very helpful in understanding about refraction, and also this experiment is actually used for calculating the refractive index of glass, because because we have drawn these pins, we now know exactly how much the light ray would have bent. Because of that we can figure out the refractive index of glass.
The angle of extend
so here see the light ray should have gone
a
like
parallel
this,
line of
but
emergence
it has
and
shifted.
a parallel line of the incident ray. Now the perpendicular.
Now I think for the video this is enough for the video. Okay, in the last video we learned about the glass slab experiment and we saw about refraction. Now in this, let us look at what is refraction actually. Okay, so refraction is, wait, let me write it here. Refraction is the change in path of light when it moves from one transparent medium to another. The change in path of light when it moves from one transparent medium to another. Okay, so note it down. This is called refraction. Is called refraction. Okay, so now see this is medium 1, this is medium 2. The light ray is traveling like this. Instead of continuing in its path, it has changed, it has bent. Okay, now how is it bent? Is it like why has it bent exactly this much? Okay, every time does it bend like this, or sometimes it does some other way? See here, instead of, let me draw this. Okay, so now here, see here, instead of coming like this, what happened, it has bent towards the normal. Here, instead of continuing like this, it has bent away from the normal. Okay, so sometimes it bends like this, sometimes it bends like that. And also the scientists have had observed that, see here, if it was air, and here if it was water, okay, then if the light comes like this, it has bent like this. Okay, every time it will bend in some way. But as soon as we replace water with glass, the amount by which the light bends actually changes. Okay, so see, it is, the reflection was very simple. All we had to do was, it comes here and then it reflects back in the same angle. Okay, that was very easy. But in refraction, there are so many things changing. Whenever we encounter something like this, we should investigate it more and find out exactly how it is happening. Okay, so similarly, scientists also, they have observed it carefully and they have come up with some laws. ನೋಡಿ, ಇದು ಒಂದೊಂದ್ಸಲಿ ಒಂದೊಂಥರ ಬೆಂಡ್ ಆಗುತ್ತೆ ಅಂದ್ಕೊಂಡು, ಅಯ್ಯೋ ಒಂದು ಗೊತ್ತೇ ಆಗಲ್ಲ ಅನ್ನೋ ಥರ ಆಗುತ್ತೆ. ಅಂದ್ರೂ ತುಂಬ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ಮೇಲೆ ಲಾಸ್ ತೊಗೊಂಬಂದಿರೋದು, ಅದಕ್ಕೆ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಅದು, ಆಯಿತಾ? ಇವಾಗ ಇವಾಗ ನಾವು ಇನ್ನು ರಿಫ್ರಾಕ್ಷನ್ ಹೆಂಗೆ ಅಂತ ನೋಡೋಕ್ಕಿಂತ ಮುಂಚೆ ಮೀಡಿಯಮ್ಸ್ ಏನು ಅಂತ ನೋಡೋಣ. ಮೀಡಿಯಮ್ ಅಂತಂದರೆ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಮೀಡಿಯಮ್, ಆಯಿತಾ? ಯಾವ್ದ್ಯಾವ್ದಿರುತ್ತೆ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಮೀಡಿಯಮ್ ಅಂತಂದರೆ? ಇಟ್ ಮೈಟ್ ಬಿ ಗ್ಲಾಸ್ or water or air, and what else is there? Oil also is a transparent medium. And what else is there? Kerosene. All these are transparent mediums. Okay, now see, the medium in which the light travels more easily and so can travel faster is called rarer medium. Okay, so light, if it is able to travel easily, ಯಾವ್ದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಈಸಿ ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತೆ ಲೈಟು? ಯಾವುದರಲ್ಲಿ ಜಾಸ್ತಿ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಆಗಿರುತ್ತೋ ಅದು ಲೈಟ್, ಫಾರ್ ದಟ್ ಮೀಡಿಯಮ್ the light will be able to travel faster. So the medium in which light travels with more difficulty and hence becomes slower is called a denser medium. Here we have used denser and rarer. We have not used dense and rare. We have used comparative adjectives. Do you remember this from your English? The positive, comparative, superlative adjectives. That is dense, denser, densest, rare, rare, rarer, rarest. So when we use comparative adjectives, it means we are comparing it with something. So here, what are we comparing it with? Let us see. So if the light is traveling from one medium to another medium, then let me draw this. So this is the surface, this is medium 1, this is medium 2, and if light is traveling from one medium to another, okay, then if it is traveling more easily here and after it enters this second medium, it becomes more difficult for light to travel and it becomes slower, then the medium 1 is rarer medium, medium 2 is denser medium. Okay, and ulta, if medium 1 it is difficult to travel, okay, but sorry, medium 1 if it is difficult to travel, but in medium 2, as soon as the light enters it, if it becomes more faster, okay, then it is, medium 1 is called the denser medium, medium 2 is called rarer medium. Okay, now let us see some diagrams. See here, kerosene, this is kerosene, okay, this is water. So how will light travel? First of all, it will come in air, it is very fast, so fast it will come like this, so, and then in kerosene it is, you can see it is not as transparent as air, no, so it will travel little slowly, but as soon as it reaches water, again it is not as fast as air, but it travels faster. Okay, so here it is the fastest.
fast, slow, little fast, like that it will travel. Okay, similarly here also, this is just a glass of water. If the light is going like this, first it will encounter a glass. In the air it is traveling very fast, in the glass it will become slightly slower, in the water it will become again slightly fast. Okay, now let us look at where the light will go when it is traveling from rarer to denser and denser to rarer.
Okay, so when the light ray travels, how it exactly bends? So what the scientists observed is when the light ray travels from a rarer medium to a denser medium, that is, okay, let me make this color red. Okay, when for example air and water, between air and water, which is rarer? Air, because air is more transparent than water, correct? No, you have to remember this. Okay, in sound, if in sound traveled easily in water because water molecules are close to each other, so it was easier for sound to travel. But when it comes to light, light travels easier in air because air is more transparent. Okay, now the scientists observed, let us always draw a normal for reference. Now when it travels from rarer medium to denser medium, light bends towards the normal. See, it should have traveled like this, but it bent towards the normal. When it is traveling from a denser to rarer, between glass and water, what is rarer, what is denser? Glass is more denser because it is water, clear water is more transparent than glass. Okay, here also let me draw the normal. When light is going from glass to water, that is from, this is the denser medium, it is going to a rarer medium. Here this was the rarer medium, this was the denser medium. So if it is going from denser to rarer, then it moves away from the normal. Okay, this is very important to note. Okay, note it down. When light travels from rarer medium to denser medium, it bends towards the normal, but when light travels from denser medium to rarer medium, it bends away from the normal. So this is the observation that the scientists have made. Rarer medium means like air, where it is more transparent. But it is like between two mediums. If it is between glass and water, water is rarer because in water is more transparent than glass. Air and water, air is more transparent, so air is rarer. Understood? No? Okay, so let us close this. Let us come back to this picture. Okay, now when the light is traveling from air to kerosene, which is the rarer medium? Air is the rarer medium, so the light will come like this. Okay, now let us draw normal. Okay, if it was traveling straightly, it would have gone like this. Now denser medium, this is the denser medium, right? This is denser, this is rarer, so light will bend towards the normal from rarer to denser, so right, it will move like this. Understood? No, towards the normal. And now again we have to draw normal at surface between kerosene and water. Okay, straight line means after the deviation it will come like this, it should have come like this, but it bends away from the normal, so it goes like this. Understood? No, so this is how it actually travels. So it comes from air to kerosene, bends towards the normal because kerosene is denser. From then between kerosene and water, which is denser? Kerosene. So water is rarer medium, so denser to rarer it is traveling, so it bends away from the normal. Okay, now let us look at the laws of refraction. Okay, first law is that the incident ray, the diffracted ray and the normal to the interface of the two transparent media at the point of incidence all lie in the same plane. This is very similar to the second law of reflection. It is very easy. Again, incident ray, normal refracted ray at the point of incidence all lie in the same plane, which means we can draw all this on a sheet of paper. Understood? No? No, okay, pretty simple. Now let us go to the next law. This is the very important, okay? Because just see here, I told you that this angle, even in the same medium also, so if it is always water and glass, for example, it bends in a particular way. But if it is water and air, it bends in some other way. So whenever the medium changes, okay, the light always bends in a different way. So if it was traveling from air, if it goes to water, then it bends towards the normal. But how much does it bend? Correct, no? So instead of going like this, it has bent here, because this is water, it is air, and this is denser, so it has bent towards the normal. Now if it was glass, because glass is even more dense, it would have bent even more towards the normal. Okay, so with every medium it bends little more differently. Between kerosene and glass, which is more rarer? Glass, because glass is more transparent than kerosene. So then if it was kerosene, it would have bent even closer to the normal. Understood, no? So let us see what the second law of refraction states. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of given color and for the given pair of media. This law is also known as Snell's law of refraction. Okay, what they are telling is sine of angle of incidence by sine of angle of refraction is always constant, which means here if it is incident at particular angle, it is refracted at a particular angle. Here this is angle of incidence, this is angle of refraction for a given pair of media. That is, if we are traveling always from air to water, then this ratio will remain always same. So if it travels at, if it comes at, this is 50, you think, or 30 degree, this is 20, you think, then what is refractive index of this? I did not tell you what is refractive index, no? Okay, wait, this, there is a, what they have told is this a constant, it is sine of angle of incidence. So sine of angle of incidence is sine 30 by sine of angle of refraction, so sine of 20. Okay, this is one constant. Now if it comes at some other angle, for example 50 degrees, this total thing is 50 degrees, you think, then it will bend in such a manner that whatever it bends at, okay, let us assume that it becomes theta. Okay, theta. So then this constant will be equal to, again sine of angle of incidence is 50, sine 50 divided by sine of angle of refraction is sine theta. Okay, so this is what it means. So if it comes at one angle and goes at one angle, the ratio of the sines of those two angles will always remain constant. This is very nice law. Okay, now we can find out the angle by at which it will do that. Now let us look at the textbook. So it is also okay. So after this constant value is called the refractive index of the second medium with respect to the first medium. Okay, so in reflection it was very easy because reflection did not depend on the medium, but refraction depends on the medium. Okay, so here if light is going from air to water, it will bend towards the normal. If it is going from, let us, this is air, this is water, and if it is going from water to air, it will bend away from the normal. Okay, so now uh, this is when it is traveling from air to water, angle of incidence is towards the air. Okay, angle of refraction is towards the water. So sin I by sin r is constant, that is, this is constant value is called refractive index of second medium with respect to first, that is second medium means where it is getting refracted, that is refractive index of water with respect to air is sin I by sin r in this case. But in this case I is in water, correct? No, incidence is happening in water, refraction is happening in air. So sin I by sin r, that is when it is traveling from water to air, whatever we get answer, that constant value is called refractive index of air, because here air is the second medium, because air is where the light is getting refracted into second medium. So refractive index of air with respect to water. Okay, now if this was glass, this was water, and if light ray is traveling like this and it moves away from the normal or towards the normal, this is straight line path. Glass is denser medium, water is rarer medium, it bends away from the normal. What is the angle of incidence? This one, angle of incidence. So wherever angle of incidence will be there, that is the medium 1. Wherever angle of refraction is there, this one, that is medium 2. So here sin I by sin r is equals to what? This is equals to refractive index of medium 2 with respect to medium 1. Medium, that is of water with respect to glass.
This refractive index is denoted by N 2 1. Okay, N21 is refractive index of medium 2 with respect to medium 1. Okay, so 2 is equal to refractive index. So N21 is refractive index of medium 2 with respect to medium 1. Note this down. Okay, now here, which is like here, if we look at sin I by sin r, what we will get? N21. Okay, let me erase it here. Okay, now in this particular case, N21, that is sin I by sin r is equal to N21. Here N2 is always where refraction is happening, so that is N of 2 is water, 1 is glass, correct? No, so here N of 2 water with respect to 1 glass is equal to sin I by sin r. Here N21 is what? N2, here sin I by sin r equal to N21 is equal to N2 is which one? Wherever incidence is there, 1. Wherever refraction is there, 2. Water, air. Of water, refractive index of water with respect to air. Here incidence is happening here, 1. Refraction is happening here, 2. With N21 is an air, water. Okay, now so if in the exam they have given this diagram, okay, they have given this diagram and they have asked you what is the refractive index of glass with respect to water. Of glass with respect to water means in N21 it is medium 2 with respect to medium 1. So glass with respect to water means glass with respect to water. We have to find out. How to find that out? If we do sin I by sin r in this diagram, we will get water with respect to glass. So N21 NGW equal to ulta of this one, okay, divided by NWG. So this is a formula that you have to note it down. Okay, so what is the formula? N12 equal to 1 by N21. Okay, So whenever there is a problem, that is they have given like this, they have asked you instead of, if you do sin A by sin R, you will get n water glass, but you want glass with respect to water. Okay, then you have to do 1 by that one. So this formula also note it down, it's very important. Okay.
So now we have looked at the refractive index formula, that is sin I by sin R equal to n21. Okay, that is from this diagram where incidence is happening, that is medium 1, where refraction is happening, that is medium 2. This we have seen. Now we will see one more formula. Okay, n21 is equals to speed of light in medium 1 divided by speed of light in medium 2 is equals to V1 by V2. This is one more formula. Okay, so combining both of them, we will get n21 is equal to sin I by sin R is equal to V1 by V2. See, medium 2 with respect to medium 1, here incidence is happening in medium 1, refraction is happening in medium 2, and V1 by V2. Okay, note this down, this is very important. Okay, if medium 1 was air, then what will happen? This will become N2 air, correct? No, so N2 air, medium refractive index of medium 2 with respect to air is equals to velocity of light in medium 1, that is medium air divided by V2. Velocity of light in air is a constant which is called as c by V2. This c is speed of light in air. Okay, speed of light in air or vacuum. Okay, and the value of c is 3 into 10 power 8 meter per second. This is the velocity of light in air or vacuum. Okay, just imagine how much this means. 3 into 10 power 8 meters per second, that means it is like 3 and 8 zeros in front of it. So it is like I think it is 3, okay, let us divide by 1000. 3 into 10 power 5 kilometers, that is 3 lakh kilometers per second. Can you imagine the speed? Okay, so that fast light travels. Okay, there is nothing which travels more faster than light according to today's science. Okay, so now this, when we are comparing any medium to air or vacuum, then that refractive index is called as absolute refractive index, and it is just given as Nm, that is refractive index of a medium. Okay, so let me show you why that is. Okay, so whenever we are telling, for example, if we want to know refractive index of glass, but we have to refractive index of glass. Okay, now with respect to what, we have to have some standard here again, because we can find refractive index with respect to water, oil, air, anything, but we need one simple reference, so that if we just tell this is the refractive index, okay, refractive index of glass is 1.4, if I tell, then you should be able to understand that if we are telling with respect to air only. Okay, so if with respect to what it is not mentioned, and if it is just mentioned n glass or n water, then it is assumed that this is absolute refractive index, and it is given by velocity of light in air by velocity of light in glass. Okay, similarly this also is velocity of light in air divided by velocity of light in water. This is called as absolute refractive index. Okay, so this what is absolute refractive index is equals to refractive index of any medium with respect to air or vacuum, and 2 1, where medium 1 is air, medium 2 is any medium, then that is called as absolute refractive index of that medium. So in the question, if we don't specify with respect to what, it is assumed that it is with respect to air. Okay, note this down also. Okay, I think now we can end the video here. Let us continue in the next video. Thank you. Bye.